Well, hello Aces fans. We're here at our manufacturing to give you guys a little bit of a sneak peek about the processes that our throttle bodies go through. Now, I've got a few different here spread out on the table. I've even got the ECUs as well. These are the cast aluminum housings that protect our circuit board, because you guys, I know you love the remote mount option that we have on our systems, but it is cast in aluminum and very nice quality. Through this whole thing, we're going to go through the casting procedure, some of the machining procedure as well, and what it looks like pre and post, and a little bit more of the final result before we get laser etching and putting all our logo on here. But I mean, we got from raw casting that's just had a tumble polish done to it to near finished product here, and our Killshot Pro. So this is a different one. Even how the discharge rings are put in here is completely different than the previous Killshot generation. So with this, we're going to take a walk through the factory and give you guys some behind the scenes on exactly what goes on with these throttle bodies. So let's get after it. Okay, so here we are at the machine that actually injects all the aluminum, and this right here is the final product as it rolls off the assembly line. This is AD12 casting aluminum. It's pressed in at about 700 tons of pressure, which actually makes it quite strong, with flexibility in all the right places because of how much temperature and pressure this thing is made with. Now, this is the very, very first stage of this whole process. All these little bits and pieces still have to be knocked off to get this piece right here. So this is all the extra bits taken off, and we're going to go to the next level of machining with it, and I can't wait to see what happens next. So hang in here with me. Let's walk through the whole process. Check that out. So welcome back. So we decided to go around the whole process of the ultrasonic, and we did something a little bit scarier. We got some x-rays going on, and we're checking internally of how many little voids there is, and we're doing it to like a level 2, which is extremely tight. Like level 1's a whole different thing, but yeah, that's crazy. Level 2, we're looking for very minimal amount or very minimum size voids inside this casting. So we actually got one of our parts in the machine right now. We're getting ready to hit the go button on this and see what's inside of it. So I'm excited as can be, because not everybody is going to do x-ray testing. Not everybody is going to do anything to do with NDI or NDT or even the CMM checks that we're doing here, because we don't want to put out a product that is inferior. We want to put out a superior product, and especially with the new product line of the Killshot Pro, I was like, we're gonna bring this to the market on a high level at a very affordable price. So let's go x-ray something. All right, so now we've got our throttle body back. Now this has gone through our ceramic coating process, which is not in this facility, but we receive them back here just to put them in our 4-axis CNC machine. Anyways, this is a high-speed smart T8 CNC. It's got 30 tool capability, but we only load 28 of them in there because that's all we really need for our process. This machine right here, it's pretty high speed, very efficient, but it's a two-parter. So it's going to do one side, front and back, then we flip it, insert this throttle body back in here, and after it's done with this side of the process, it ends up looking just like this. Nice and machined and beautiful and ready for the next bit of assembly. So we've got the injectors done, everything like that. It's ready for the cryo stage where we put the discharges inside of it. I'm excited about this, and this is the Killshot Pro. So these things are coming at you faster than you like. So yeah, let's just keep moving forward on this, and let's see what the next stage of this looks like. So we got our throttle body all machined up. We got it off the 4-axis. Now we need to get it measured, and we do have a really good quality lab here. So let's go get this thing dimensionally checked against our drawings to make sure it's suitable for you, the customer. So come with me. And welcome to our quality lab. So we do a lot of non-destructive testing here, which some of you Aces fans may be familiar with. I mean, we do have a Chroma by Hexagon CMM machine. It's good about 3,000ths in tolerance, and we do put it on there. We jig the thing up, and we touch off on all the important places on this actual piece itself to make sure it's dimensionally correct by our drawing, by our standards. And we do have some pretty tight tolerances. There's a lot of zeros and ones and decibels, but they're all very important to me. So I'll go ahead and I'll move this thing forward a little bit and talk you guys through some of the testing we actually do here. There we go. So as well as CMM, which is, coordinate machine measuring, which is a kind of an industry standard when you get to higher levels of quality when it comes to these things. But we also use different stuff like durometers to check the hardness of the aluminum itself from time to time, just to make sure that the batch of aluminum, every time we get a new batch, we check that to make sure that it is the correct quality and the correct hardness, and to see if we need to do any tweaks out there on the production floor as well. And we also do a lot of NDT as well, so non-destructive testing like ultrasonic and still more visual checks. So we run our CMM back here. We're going to go through the test results here shortly. Might not be able to talk about all of them. Some of this is proprietary after all, but if it's kind of a go, no-go situation. So it's either going to meet the quality check or it's going to fail, which will make more quality checks to make sure we're hitting all the numbers that we need to hit. So we'll let this machine run and do its beautiful job, and we'll talk a little bit more about some NDT. So we're still here in the CMM lab. This is an important portion of this testing that I wanted to go over with you. I already reviewed some of the results, and we're talking about a 2,000ths tolerance, which is right around the neck of the woods of LS main bearings and whatnot. So I mean, we're keeping it tight, but this is the important part where we're checking the bores. So if we don't have that exactly correct, if it is one of the tightest tolerances we have, if it's not perfect, I mean within a very long number, you're talking about throttle shafts could bind, the cryo process of putting the actual discharge nozzles in there and everything, or the annular discharge nozzle, could actually bind it a little bit and cause all kinds of weird fuel problems. So I'm going to fast forward the machine right here. We're going to get to checking the bores, and it's exciting. I love this kind of stuff because I'm all about quality. So right now we're touching off on it. We're getting a whole lot of green lights so far. So every one of the coordinates it's touching off of, it's comparing it to the model as it goes. And yeah, we've got nothing red yet. So this is very exciting. If this thing passes, we're going to move this along down to the next lab as well for a little bit of ultrasonic testing as well. Like I mentioned a little bit ago, some NDT, or non-destructive testing as it's called. Now this is a climate-controlled room. It's between 58 and 62 degrees Fahrenheit, so it's really nice in here. It's a little warm outside for me, and in here it's really quite pleasant. So every time I get the opportunity to come here to do this kind of stuff, it's my favorite room. And I mean, there's a lot of really high technology here. I mean, who else has a bridge CMM just hanging around, right? So we're touching off. We're still looking good. Some real positive vibes for our measuring. And I'll try to get you guys some good close-up footage of what's going on down in here, and we'll continue on this process. Thank you.